if this case is there, current is going like this, that means the positive charge is going up like that. It's the Q that is going up, plus Q. The electrons are going in the down direction. If it's plus Q, it's Q cross B. It is the B field that is going in. Then what this force that I'm going to experience FL is going to be simply V cross B in a direction. Yeah. So V is going up, the positive charge going up. Current is opposite to the flow of electrons, right? So current is in the direction of positive charge, which is going up. My fingers are going up. Cross B, which is going inside, yeah, which is going inside. That means my thumb is pointing to my left, yeah, which is why the force the wire experiences is going to be in this direction. If the direction of the current changes, that means my FL is going to be in the opposite direction. So again, use your right hand and do the cross product. So clearly you can see the application of cross product coming up here to describe the nature. Now comes how we can use of the Lorentz force of that small q, that how that current element, we can go ahead and define what is called as a current element, which is IDL. That means a small little section here, or a small little section here, or a small little section here. If I were to take that small little current section and call that the amount of current that flows through it is I, that current element is going to be IDL vector. So my small little Lorentz force due to that small little current is going to be IDL cross B, which is the same as QV cross B, the same Lorentz force that's exactly manifesting in this form. Again, as you see from the previous studies, that if I have the small little force due to the small little current section, then I can find out what is the total force due to all these different sections by integrating it along a closed curve. This is a closed curve or a loop. When I say C refers to a closed curve or a loop. So this expression might appear different to you, but in essence, the idea is this. This expression reduces to IL cross B, where this L vector is essentially this integral. This L vector is essentially, this integral is replaced as the L vector, and that is valid. This replacement as L vector is valid only if this section is a straight wire. Meaning what? This is only valid for a straight line segment of current. If it is a curved segment of current, then this replacement is not valid. You have to integrate it along that line. You have to integrate that along that line. But since it's a straight line, you just do the integration along the straight line. It is as good as its length. It's as good as its length. So for straight wires, you don't have to do this line integral, yeah? So it is going to be simply IL cross B. It is the current element IL cross B. L being the length along the wire, yeah? So it's L is the length and L hat is this direction, the direction of the current flow. So this force acting on a current carrying wire is the key principle for the working of an electric motor. The important thing is, when I have a wire, if there's a current flowing through it, I place a magnetic field, it's going to experience a force. And that force is going to be this expression, which reduces to simply this form, where the current segment is simply a straight wire. Where the DL, integral DL, is going to be simply the length of that segment. But then here we say it's a closed loop, right? How can you create a closed loop of wire with line segments that are this? what you can do is create a rectangular coil. Yeah, that's one approximation. You can also have a circular coil. So as I said, circular coil, you have to do this line integral along that line. So what you're having is only straight line segments, so that integral is already the length of this line. The integral along this segment is going to be length of this. So if this is A, this is B, then it's going to be, the length is going to be B.